Okay.
Hi guys. Hi Ritik. Hi Abira. Hey, what are you doing in class, ma? Ritik, Abira. Nidhi, how was the vector test, Nidhi?
It was easier than I thought it would be.
Oh, good. And how are the word problems?
There was only one word problem. I found it hard at first, but then I solved it with some geometry.
Some, I see. Was it any useful that I sent?
Yeah, it definitely was.
You were able to go through. Did you have time? But I sent it very late, right?
Yeah, I went through it in the morning before the test.
You so sweet, Amma. Okay, that's fine. So you got something out of it. Ma, sorry. See, the sequence is changing. I don't mind switching, but it'll be just be messy, I felt. That's why I'm not switching. I know that you're solving vectors in school. Okay, but we'll go to vectors soon after parametric equations.
Yeah, that's fine. We're gonna start polar graphing and everything on Monday, so
You find
I'm
it very
prepared for
useful.
that for sure.
Nice. Vibha, what are you doing in school, ma?
Right now we just had our last test. It was over the cotangent, like trig identities, all of that.
Okay, then what is the next one for you?
Um, everything's done. Wait, let me check my calendar because we don't have any more tests coming up, so I'm assuming it's just review, but we might just be learning like extra topics, but we
Review, na, when are they going to cover polar graphs, vector matrices, all
um
that,
let me
parametric equations, all that is a part of pre-calc, right? AP pre-calc.
um they don't have anything else. Everything they just say AP review for the rest of it. They don't have a calendar for anything else.
Oh, wow. Did I not see properly then? Okay, let me check. I know yours, the Dhyani, I don't have to ask. Abhiram and Ritik, what are you discussing in school?
We're just doing polars. We did polar rates of change, then average rate of change. Now we're about to have the test on it next week.
The polar rate of change is something I'm going to cover today. Okay, it will be only short, but then I want to go to parametric equations. Have they covered parametric equations?
No, not yet. I don't think so.
Let me quickly check. One more another thing that I wanted to discuss before even we go into 1 second, guys. Before even we go into our thing, I wanted to discuss. Hey, your pre-calc exam is on May 13th, right?
Yeah.
Is it, so the last class, right? I would want to do it well before. 1 second, guys. Uh, Okay, yeah. Guys, you have polar function. See, unit 1, unit 2, unit 3, we have completely covered in class. Okay, unit 4 is parameters, vectors, and matrix. 100% it is there, and they have to cover in. Oh, not assist for the AP exam. Oh, I see. Okay, guys, let me share a screen with you. You guys have to know what is going on as well. Naisha, what happened to that problem, Naisha?
So the thing that was happening with the problem is that it wasn't 2x minus 1, it was 2 pi x minus 1. So you divide by pi first, so then it would be in terms of like without pi, and then you'd minus 1. So that's why.
So you got the answer.
Yes.
Okay.
Mhm.
Now, hey, see, guys, this is what I'm seeing. Okay, I go to College Board website. Whenever you say something, I go to College Board website and verify. So, just I want you guys to know. First of all, let me share my screen. Where is that screen? Google Chrome, AP pre-calculus. Oh, yeah. Do you see my screen? Okay.
Yeah.
So now do you see here we have covered what? Polynomial rational functions, exponential logarithmic function, trigonometric polar functions we have covered, right? Coming to trigonometric polar functions, um, see, graphing functions using polar coordinates we have done. Describing how angles and radii change with respect to each other in a polar graph is exactly the rate of change in polar functions, which I have not covered, which I thought I'll do it today. Coming to the last unit, right? Describing how quantities change with respect to each other in a parametric function, graphing conic sections using implicitly defined functions and parametric functions. So this is what I plan to do today. Not everything though, but then I would like to finish up the last part of unit.
Auntie,
Yeah, ma?
I don't think we're going to be using Unit 4 at all in school because according to that, it's not on the AP exam, so they're not even teaching it in school.
Ma, but that's quite important, Amma.
Oh yeah, I'm just saying they're not teaching it.
I get it, but see, you know, vectors,
Oh, Miss
yeah,
Priya, for
yeah.
that unit,
Mm.
they're spending a day on parameters, a day on vectors, and a day on matrices in school.
A day, 1 hour.
Yeah, like one class period.
Oh my gosh. So that's it?
Yeah.
Okay, so you tell me, guys, then, okay, then see, honestly, I did not see this. Okay, I wanted to cover everything out of this. That was my plan, and that's how I have my lesson plan as well to finish. So I was a little worried whether I'll be able to finish as well. That's why I was saying, hey, why don't we prepone one class? Having said that, right, I am okay to do whichever is going to be productive for you, I would do. Okay, so for today, I'll definitely go ahead and finish what we have. You see, rate of change of polar functions we do have, right? So I'll go ahead and do that. um, I want to do this parametric equations, you can know, but I would like to start a review for the AP exam as well. So what do you want me to do? Do you want me to cover this, or do you want me to go back, like just give an overview, leave it there? You want me to do that?
Could
I'm
you do
open
an
for your
overview?
thoughts. Huh?
Could you do an overview of Unit 4?
Overview on unit 4. You don't want me to go in depth?
Wait, Auntie, will we need
Wait,
Unit 4 for AP or AP Calculus?
Hmm. I'll tell you, meaning math is not like you just learn, throw it and go. It's not going to be like that. When you go to your college, right, everything is going to play a part. You will know this part if you do this now. There will be others who are like you, who studied only at school, they did not do it. You see, so who can, meaning in that case, in a class that's common to all, nobody is going to bother whether you understand or not. The professor is not going to bother. He will just come, teach, go. So will you understand, or will a person who has not gone through vectors and matrices will understand? You see what I mean? You're going to do calculus, you're going to do calculus 1, calculus 2, calculus 3. You need everything, vectors, parametric equations, all these form the basics, right?
Okay, can we learn it then if
Okay, see, I'm not convincing you to learn. Please don't take it that way, any one of you. Don't take it that way, but I'm just telling the advantages and disadvantages. Okay, I will leave it absolutely to you. Whatever is useful for you is what I want to do in class as well. You see, but frankly, as a person, I'm very, very sad to see what has happened to pre-care. I never saw this. Okay, initially I did, but I think I didn't give a heed to it. Now, since you all brought it up, I'm seeing not assess for the AP. See, the previous kids, previous year kids that studied honors pre-calculus studied a ton more than you guys are doing. Okay, they studied very hard problems than what you did. Okay, I feel like pre-calculus has been dumbed down a lot this year. With only 3 units they are going to teach you in school, or they're going to quiz you only on these 3 units. Whereas the previous kids, right, they learned a ton more. Not just this, the problems, the intensity, the difficulty of the problems handled were a lot much better. Now it's very easy. It's another course looks like, but anyway, that's what it is, right? So I'm open to your thoughts, guys. You can think about it and let me know. Based on that, I'll go ahead as well for next week. Let me know. What do you guys think?
I was wondering, I really wanted to go into Unit 4 because I know it's not going to be on the AP test, but I wouldn't it be useful for like when you do further math?
1 second, ma. Okay. So okay, let's go ahead then. Okay, you want it. Others, Ritik already said he wants to have an overview. Abhiram, any thoughts? Abhiram?
Auntie, can we learn it?
Yeah, sure. We'll learn. We'll definitely learn. Let's see. How about Abhiram? Nidhi has already learned vectors in school, I know. See, your school has covered a lot. Vectors with the whatever word problems you gave me were really nice ones.
Can we
Yeah.
focus more on vectors and matrices?
Sure.
Because I feel that's harder.
Sure.
For the
Yeah,
vectors, that's the only thing they're gonna do out of Unit 4 in my school. They're not gonna do parameters
parametric
or
equation.
conic sections or matrices.
Oh, I see. Oh, I see. Oh my gosh. Okay. See, only from you guys I learn all that. Okay. Abhiram, you're there? Nitin, what are you doing in school? I think I'm wasting time of the class. Nitin,
Yeah,
what are you doing in school?
we're just relearning everything. We're done with like the main units, like the main, yeah, every like topic. We're just reviewing for the AP exam now.
Oh, so you're also not learning vectors, parameters, huh?
No.
I don't know what to say. Yes. I don't know. Okay. Okay, anyway, we'll finish for the last part. Then it's like we are done, right? No, I really want to get into, meaning I have 4 or 5 classes planned on these. But anyway, I'll give an overview. As you say, I'll give an overview, some in-depth problems which you can try and come back and ask. Okay. At the same time, we'll go ahead and solve from some marks or whatever. We'll do that.
Can you hear
Does
me
that
now?
make Huh? What, ma?
Can you hear me now?
Yeah, Abhiram, I'm able to hear you.
Okay.
What are
Yeah,
you
we can do that
Yeah, but what
next unit.
what are you doing in school? I want to hear.
Oh, in school we're doing polar graphs. We're graphing the polar on the polar coordinate. And then
But are you using something that we learned, Abhiram?
yeah, we're using the like the polar functions and then like the cardioids.
Yeah, yeah. Are you able to use what we learned here?
Yeah.
Okay. Okay, but after that, what are you going to learn? Do you know?
I don't know that. I think it's conic sections.
Conics. See, you're learning conics. That's good. Okay, then.
And then I think we're gonna like touch on matrices and then
Oh,
I
that's
think
nice.
that's the last thing.
Okay. 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 I'll try, guys. I'll get at least 2, 3 mock exams somehow. Okay. I'll put it down. You take the test at home and come and ask questions that you have. Or if there is a particular area where you need review, bring it back to next class. See, we have only a few classes remaining, right? Meaning your exam is on May 13th, right?
Yeah.
See, I was asking for this class, 16th class, to be preponed. Then only it's useful for you all, right? So let me see if I can prepone the 16th class to somewhere on a Saturday or a Sunday. So that way we are done with May 13th and you can take off with that, I feel. Meaning we'll be done on May 9th. Does that sound like a plan?
Okay.
Yeah, so this one class, I'll bring it in front. There's no point in having a class on May 16th for pre-calc when you're done with May 13th. Okay, first I thought, see, the makeup day was 22, I think. I don't know where I saw this 22, so I was happy we are finishing it. But this morning I saw it was on May 13th, so I'm going to prepone the last 16th class to a little before. Sorry, I'm not sharing my screen at all. See, the 16th, May 16th class, I'll prepone it to somewhere 10th or 11th or whatever.
How
Okay.
many more classes do we have before the AP exam?
It's 12th, right? 1, 2, 3, 1, 2, 3, 4.
Okay.
Makes sense.
Yeah, so next week we'll just go more in depth on parametrics and
Uh,
vectors and matrices.
Today, I would really like to do the last part of Unit 3, the rate of change of polar graphs and parametric equations. Okay, conics vector matrices is remaining. I'll look, guys, now that you're saying it's not a part that's going to be assessed, right? So at least I'll cover the basics of all of these. Make sense?
Mm-hmm.
But in between, we can put in some marks or some practice for 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 topic by topic that you have the AP exam for, which will be useful for free response questions and stuff. Sounds like a plan?
Yeah. Also, is it possible if you could post any like practice AP exams we could
Oh, yeah,
take?
yeah. That's what I'm thinking.
Okay.
I was really worried. Okay, I didn't see this not assessed for AP exam, so I was planning how to finish it, prepone that one class and finish the current curriculum of 4th unit is what I was thinking. Now that we have this time, right? So let me go over till parametric equations today. Vectors, conics, matrices, we'll do 1 week, we'll allocate, or 1.5 weeks we'll allocate. Other than that, we'll practice marks. Make sense?
Yeah.
Yep. 1, 2. Am I calculating it correctly? 19, 26, 3, 10. That's all. 19, 26, 3, 10. Oh, yeah, you don't need to prepone a class as well. You're having a class on Saturday. Yeah. So we have just 4 classes. That's good. Got it. I was wondering if we are not able to complete that 4th unit, I will have a class like a 10th extra class, I was thinking. But just now I saw that it's not being assessed at all. So 4 classes, we'll utilize only 1.5 class to review, to go over the stuff in unit 4. Other than that, okay, I'll make sure I post marks as well. Make sense? Okay. Let's go back. We wasted enough time today. You know what? Okay. What did I want to do? Rate of change of. It makes me feel good that it's not a part of the AP exam. Anyway. Okay. Let's do this one. Ritik, you have covered this in school, right? Already? Rate of change of polar graphs.
Yeah, we have. We covered it on Friday, or no, Thursday.
Okay. Let's see where we are on
But
that.
it was a bit hard to understand.
Okay, we'll go over it. Rate of change of polar graphs. This one is not as hard as graphing, very frankly. Let's see.
Wait, Auntie, is this 3.14?
Is it 3.14? You want me to check and tell you? I don't want to say incorrectly. Hold on. 3.14. Is it 3.14? Rate of change of polar graphs, Amma. 1 minute. You know. Hold on. Polar, no. This is 3.15, ma.
Oh, okay.
Why?
Well, I was just wondering, so I can also look at my notes that we did in class also.
3.15 ಇದು. 3.14 is the polar graphing.
Okay.
The 3.14a polar graphing starts, 14b polar graphing ends.
Mm.
Does that make sense?
Yeah, thank you.
Okay. Now, rate of change of polar graphs. Let's see this graph. So here, 6 sine 3 theta. 6 sine 3 theta, right? In a rectangular coordinate, this is your graph. In a polar coordinate, this is your graph. We want to understand the rate of change in these intervals. So there is an easy way to understand this well. So let's go over that, come back and fill this in. Okay. Now, I really want you to compare. Okay. From 0 to pi by 6, what happens? Let's do it here. 0 to pi by 6, right? What happens here? It increases and the y value is positive. Can I say like that? It increases, y value is positive. Now, pi by 6 to pi by 3, what happens? This is pi by 6. This is pi by 3. Okay. Now, the same thing I'm going to mirror here. 0 to pi by 6, it increases. Please, guys, this is quite important to understand the relation. It increases and R is positive in this graph. Now, let's come to the second. Pi by 6 to pi by 3, what happens? Pi by 6 to pi by 3. Pi by 6 to pi by 3, what happens? This is similar to this. The value of the graph decreases and it is still positive. Then Once you understand this, it's very easy to tackle any problem. Here, pi by 3 to pi by 2, it is negative and it decreases. It's going further negative, right? And the last one, it increases, but it is negative. Make sense? Any questions still here? Okay, but I did not do the same thing in here, right? So when I equate this to whatever is in the polar graph, this piece, pi by 3 to pi by 2, where is pi by 3 to pi by 2? Pi by 3 is in here, pi by 3 to pi by 2. See? And then pi by 2 to pi, right? Pi by 2 to pi. You see? Pi by 3 to pi by 2. Pi by 3 to pi by 2 is the green curve. So decreases, negative. The blue curve increases and negative. So we are able to match the rectangular coordinate with the polar form. But what are we doing? Why are we matching? Nothing is clear right now, right? So let's see. Okay. Let's see. Let's try out this one. I'm going to copy this one. One second, guys. Let me. Okay. Now we will discuss how are we going to write it in a polar curve. Let's say R is positive, R is negative. R is positive. From this one, whatever we learnt up, right? We'll put it, R is positive, R is negative. We'll come up with our own deductions. R is negative. Okay. This side, I'm going to talk about distance from the pole. That's what I want to know, because in polar graphing, if you're asked, hey, what happens to the distance from the pole when in these conditions? So in that case, now f theta is increasing and decreasing is what we need to know. F theta increasing, f theta decreasing. R equal to f theta, right? So here, let's see what happens. Okay, the bottom part is our derivation. Okay, that's what we are going to take it forward. This is just an explanation of why that happens. Now let's say R is positive, R is positive, R value is increasing. R is positive, R value is increasing. What do I say? Does it move the black one in a polar graph? Does it move away from the pole or does it go towards the pole? Guys, you have to tell me too. Guys, are you all with me?
Does it go oh
So the black part of the curve, the black part of the
goes
curve,
away from the pole, right?
does it move away from the pole or towards the pole?
Away
wait,
from the pole.
yeah.
Away from the pole, and it is increasing. Do you see it? Its value is increasing and it's moving away from the pole, correct? That's what we need, away or towards the pole. That's the main thing we need. Now, R is negative. R is negative and f of theta. R is negative and f of theta is increasing. How about this? What happens here? Let me not quote it differently. Let
Is it
me use
moving towards the pole?
here it moves, the blue one, right? Yes, it moves towards the pole. Now, let's go to the next one. Towards the pole. Good. R is negative. F of theta. R is negative. R is negative and f of theta is increasing. Yes, it moves towards the pole. Very nice. Now, how about the next one? Let's go and talk about the red color part. What happens? R is positive. Theta is decreasing. R is positive. Theta is decreasing. What happens here? Is it moving towards the pole or away from the pole?
It's moving towards.
Towards the
It's
pole.
moving towards the pole. We will deduct something, okay, towards the pole. Now, the last one is the blue one. This is just for you to understand why it happens. Just like that, you cannot conclude the bottom table. What did we leave? The blue. What did we leave? Decreases and negative. The green one we left. Decreases and negative, what happens? Decreases and negative.
Moves away from
Moves
the pole.
away from the pole. So, away from the pole. So, from this diagram, how I can easily tell it out is, when you see R is positive increasing and negative decreasing, both are moving away. When both are positive or when both are negative, when both are positive means when R is positive and the graph value is increasing, both are positive, right? The other one is R is negative and f of theta is decreasing. In that case, they are moving away from the pole. The other side, when one is negative, the other is nice. That way, they are moving towards the pole. Any questions here? Now it's going to come handy. Any questions here? See the bottom the bottom thing you should know. Another thing here which I forgot to tell you, right? Here, let's go back for the black color part of the curve, right? For the black color part of the, oh my gosh. For the black color part of the curve, right? R is increasing. Do you see it? Whereas when it is, well, let me call the blue color part of the curve. What is that? R is negative, theta value is decreasing. What happens here? What happens to this part of the curve? Here it goes down, right? Meaning it's going towards the pole. R value is what? R value is decreasing, correct? R value is decreasing, right? It is going down. Now, the red one again. This part, right? I know it's moving towards the pole. I'm only considering about the R value. R value is, what happened to that red? R value is decreasing. Do you see it? The green, what happens to the green part? Here. R value is increasing. Any questions? Increasing or away, towards or decreasing? Got it? Are we clear? So this is how we relate the rectangular polar coordinate. We place intervals and understand what is increasing, what is decreasing. Based on that, we come to the conclusion when R is positive and f of theta is increasing, it's moving away. Or when R is negative, and theta value is decreasing, this one and this one, they move away from the pole. For moving towards the pole, both of it are opposites. So let's see what happens. Let's go ahead. How we are going to use this, let's see. You will be, let's work out some examples, okay? How about this? This is one example which I thought of discussing in the class. Now, there's a table given. Theta and R equal to, this is f theta. Theta and R is given. This is function of theta. Now, let's consider the interval 0 to pi by 2. This is the interval 0 to pi by 2. What do you think about it? R is, guys, please be interactive. It's okay to go wrong, right? What is R? Is it increasing or decreasing?
Increasing.
R is
Increasing.
R is increasing. R is increasing, correct? It is increasing. Positive, right? Right?
Yeah.
Yeah.
Now, if R is increasing and positive, what did we discuss? It's moving away from the pole or towards the pole? You forgot?
It's moving away, right?
Yes, it's moving away from the pole. Okay, let me try if I can get the previous table. You guys need it, right? See, that's why those were deductions that we were about to use. I can do it if you want to. Let me see if I can give a shortened version of that. R positive, R negative, f of theta increasing, f of theta decreasing. This was what we had, right? So now positive increasing was away and negative, this was away. Okay, now here it was towards the pole. Distance from the pole decreases. If it's moving towards the pole means what? Distance from the pole decreases. If it's moving away from the pole means, if it is moving away from the pole, moving away from the pole is this. If it is moving away from the pole, distance from the pole increases. If it's moving towards the pole, the distance from the pole decreases, right? Okay, so here it's moving towards the pole. Here we had it as R positive, f of theta positive. R positive, f of theta positive is increasing. Increasing, this is as well increasing. This is decreasing, this is decreasing. Towards the pole means automatically R decreases, right? So this was what we had. So from here, once you understand how this table comes in, everything becomes easy. R is increasing and positive. R is increasing and positive. R is positive, R is increasing. So is it moving away from the pole or towards the pole? It's moving away from the pole. So distance from the pole. What happens to the distance from the pole? Distance from the pole? Amma, it is moving away from the pole. So distance.
sorry, it increases. Sorry.
Distance from the pole increases.
Wait, so the origin is the pole in the like
Yeah, in a polar graph, this is the pole. You don't call it as the origin.
okay.
Make sense?
Mm-hmm.
So, did you understand how we got this? Don't memorize this, guys. I told you how we got this, correct? So, using this, you can always find out the behavior of any function within any given interval. Let's do a few more. Okay, let's see if I think I have more examples. How about this? How about this? You can do this by yourself. You can try. If you don't know, I'll help you. This one, let's see this one. Can you do this one? Describe the behavior of the function in the interval pi by 2 to pi. Pi by 2 to pi. Why is the spotlight making a mess? Pi by 2 to pi. Do you want to try? You want to message or you want to tell it out? Whatever it is, I'm fine. But try, guys. Pi by 2 to pi. It is clearly positive. Positive values, right? But it is R is positive. We are going to only look at R. R is positive, but it is
Decreasing.
that means what? One is good and one is bad. That's how I take it. If one is good and one is bad, it's always moving
Away from the pole.
Away.
illa. See, both
Towards.
are towards the
Oh,
pole.
yeah.
Both are positive. Both are good means that's how raw way of telling you. Both are good means it is moving away from the pole. If one is good and one is bad, it's moving towards the pole. Okay, so here, what I wanted to ask you. So the distance from the pole, what happens to the distance from the pole?
It increases.
Distance from the 1 minute. See guys, here, suppose you draw a graph. This is a polar graph. Okay, this is the pole. Okay, when you go away from the pole, distance to the pole, see, distance to the pole goes on. If you move away from the pole, distance from the pole increases, right? If you move towards the pole, distance from the pole decreases, right? So here you're moving towards the pole. So distance, wherever you are positioning yourself, distance from the pole decreases. Any questions? Ritik, are we clear?
Yeah.
Abhiram?
Yeah.
Nitin?
Yeah.
Let's see a few more. The average rate of change. Let's see. We didn't do that. This one is easy, okay? It is just based out of slope formulas. Okay, let's try that. Third question is easy. What is the average rate of change on the interval pi by 6 to pi by 3? It's easy. You remember the slope formula? Y2 minus y1 by x2 minus x1. We did it right earlier. So for a polar coordinate, what do you think will happen? Same. But what do you think will happen? R2 minus R1 divided by theta 2 minus theta 1. This is y coordinate, right? This is x coordinate. So basically, what is R2? 4.33 minus 2.5 divided by pi by 3 minus pi by 6. Can one of you tell the answer, please? So basically, it's trying to find out the rate of change. Let's see. In a graph, I want you to see what happens.
Would it be 1.83 over pi over 6?
Pi over 6. So what is that?
So,
0.83 by pi over 6 seems correct. 1.83.
It's are you looking for like a number?
Yeah.
It's 3.49.
Approximately 3.49 radians. 3.49 radians. 3.49. 3.49 seems correct. Okay. 3.49 units, right? R value is on the top. So it would be 3.49 units per radian. The denominator is radian. This I call it as units. So 3.49 unit. See, slope, what do? We always say, right? It moved 5 centimeter per hour or 6 kilometers per hour. That was slope in a linear graph, correct? It was based on what you had for x and y. Usually x was always time, y was always distance or something of that sort, right? So here, how does it change? Here, let's see the graph. This graph is basically, the polar graph is this. The linear graph is, the coordinate plane graph is this, right? So in this case, right, when you think about it, this, they're asking between the interval pi by 6 to pi by 3. Pi by 6 to pi by 3 will be somewhere here, right? Between these 2 points. Pi by 6 is here, pi by 3 is here, right? So what is the rate of change they are asking? So it is the rate of change for this particular curve, right? How does it change? Changes 3.4 units per radians. Make sense?
Yes.
Now let's go ahead and try one more. Okay. How about this? These are the possible questions they can ask when it comes to rate of change in polar graphs. Let's see. How about this? Estimate the value of f pi by 4. Function value at r value at when theta is pi by 4, what is the r value? We don't have it here. So what do? Pi by 4 is where?
between pi over 6 and pi over 3.
So it comes somewhere here, right?
Yeah.
So what do? How do we find it?
We would have to find the average rate of change and then add that to the previous term.
Exactly. So we know the average rate of change, right? It's more like in a linear graph we have found. Remember, how did we do? We wrote, remember this form of, what is this form called?
Point form?
Yeah, point
Point
slope form,
slope.
right? We
Yeah.
had the point slope form there, right? Similarly, we know, so you all found out and told me the average rate of change here was 3.49. Approximately, you told 3.45 or 49 units per radian, right? So we
Mm-hmm.
have that here. You have that in here. Okay. Let's turn these as y. Let's turn these as y and x. We don't want to use that. Okay. Now, y2, x2, there are so many x2, y2 here. Do you see?
Mm-hmm.
So points are in there, x and y points are in there. We are going to plug into our equation and find it. So here, let me try out. So I'll take y, I'll take this point. Y minus 2.5 will be equal to slope 3.49 times x minus pi by 6. Does that make sense?
Yeah.
This is my equation of that graph. Okay,
So, I have a question.
go ahead.
You just substitute another value in where it says y and x defined.
Exactly. For you to find out what is the value of the function, they're asking for y. At pi by 4 is your x value. Does that make sense?
Mm-hmm.
You will get the y value, right? That is the value of r. R is a function of theta. So that is the r value. I should not, basically, I should have put this as r. I should have put this as theta. Does that make sense?
Yeah.
Where in a polar graph, you use r and theta. In a linear graph, you use x and y. So now, by plugging in theta equal to pi, what was that? Theta equal to, what did we plug in? We wanted for pi by 4, right? So when you substitute this, multiply by this, and add the 2.5, you get your r value. Make sense?
Yeah.
Yeah, we'll move on, guys. I'm not talking about computations, but if you didn't understand, Yashita, are you following, ma?
Yeah.
Let's see. Yeah, that is just plugging in. Now you're going to do this for this. How about this? I'm going to have another function. See, the thing is, see, okay, what can make it harder? I'll tell you. See, I have another example. If they just give you this, right, it will be on you to type it into your calculator. Find out the values, okay? But if I give you the table, it's going to become very easy on you guys. I don't know what to do. I can give you the table, or I can go ahead and give you just, I can let you do. Let's see, I'll give you the table now. But honestly, I think you might have to use the calculator to do this. See, I have the values for you in here, theta and r. But sometimes the problem comes when they're not going to give you the table, but they're just going to give you the function. You need to type it into your calculator. This function, get the table values. You can do any table value starting from table values can be pi, 7 pi, yeah. So it just, you can split however you want to. Get your table values from your calculator. That becomes a little harder. For now, let's not do that. I'll give you the table. I'll ask you questions. You can do that first because we don't know that yet for us to go ahead and do this. I would like
Yes,
to know.
Priya, there's a calculator and non-calculator section on the AP test. Do you know which section these kind of problems will appear on most?
They can definitely give this to you in the calculator section. They can definitely give this function. You see here, 3 plus 5 sine theta, they'll give you. Okay. Then they'll ask you, determine the interval where f is increasing.
Okay.
Okay, within a cycle of pi to 2. See, they have given on the interval as well, right? So they don't have to give this to you at all. You see what I mean?
So we just have to go through every single point and then.
Exactly. You will have to get these from the calculator. Because they have given you this, right? You're just going to type it into the calculator. We'll see that as well.
Do you type it into a polar graph or?
Yes, you have to keep the mode as polar. You have to set up such that table set when you go, you should you can type your theta values. It will auto-populate the R values. Make sense?
Yeah.
Makes sense. I mean, see, you're going to type this function.
So you would have the interval would be what would the like would you do pi over 6 like is it like
What intervals will you
yeah
put in? You're asking. You can see however you want, you can put on the intervals, meaning, but your interval should cover pi to 2 pi.
okay
Okay, between that pi to 2 pi, are you asking about, hey, how will you
yeah so if I'm putting it on the graph, if we're doing like how many radians it'll increase each time, do you want us
you can step it up, right? Meaning there is a when you go to the plot, right? We'll come there. Can we do it together? We'll do it together. Why don't we do it together? I'll do the table in the calculator shortly, but just that we'll first answer these 3 questions and then we'll go back to typing it in the calculator. Personally, I didn't do it in C, but yeah, I understand how to do it. Let's see. Let's do that. Now I gave you, right? It's not in there. Yeah, you can find out the answers to these 3 questions, I feel. Once you find out the answer, we'll move on to typing it in the calculator. Try this one. Extrema means, relative extrema means positive, peak up or peak down. Leave the C. Okay. Can you find out A and B? Finding out A and B is not hard, guys, honestly. But there are more other things that are hard. We'll do this for one problem, then try to put it in the calculator. It's a big problem. Okay, this will be the last problem, but this is a big problem. It has several other questions, 5, 6 more, 4, 5 more, 5, 6 more questions on this. So determine the interval where f of f is increasing. F means function value, which is the y value in a xy plane, which is the r value here. Determine the interval where f is increasing. Is that hard? No, I don't think so, right? I was working on parametrics.
Wait, Miss Priya.
Yeah, ma?
I know we're not supposed to do C, but I was like, I just wanted to clarify. Extrema is like that. It's the peak, right? Like for example,
Peak
would
up.
sorry, does it account for only the positive value or negative too?
This can be an extrema. This can be an extrema.
Oh, okay.
Okay, this is a minima. Extrema can be a minima or a maxima.
Oh, okay.
Okay, if I want to go in depth, right? This is a relative maxima. Okay, this is the absolute maxima. You see, between these two, this is at its peak, right? So that is the absolute maxima. You get it?
Yeah.
Now, this one is relative minima. This one is
The
relative
absolute
absolute
minimum.
minima. You got it? So
Yeah.
these 2 points are all extremas. They are
Oh.
not bothered about its relative. Oh, they want a relative extrema on the interval because we don't know the other part of the function and all. Meaning we are not there is a restriction on the domain given, right? So, so they just want one is there at least one relative extrema.
Oh, okay.
You see what I mean?
Yeah. They don't want the absolute, right?
Absolute. They don't ask absolute here.
Oh, okay. I thought it
Get
was
it?
absolute. My
Okay.
yeah.
Absolute is hard to find.
Thank you.
Oh yeah, you are right. You got the answers, I think. I went to 2 pi. Is that right? Oh, correct. Correct. Oh wow, Nitin, that's correct. 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 All of you got it. Abhiram got it. Letter maximum. Really? Letter maximum at pi and 2 pi. I get it. I get it. Okay, all of you got it. But is there somebody, Supraj, are you doing?
Yeah, I'm
Working on? Okay, some Naisha, can I help you or you know?
I'm sending my answer right now.
Sure. Well, if you didn't get it, you don't have to think twice and all. You can just ask. At the end of it, this has to help you with school. 3 pi by 2 pi, 3 pi by 2, 3 pi, 3, comma, pi. Oh, okay, correct. Naisha, correct. So let's try this one. So to answer to everybody who have not answered, right? There are some people who have not answered. So this is 3 pi by 2, comma 2 pi. This one is determine the interval where f of is decreasing pi, comma 3 pi by 2. Yep. And then is there? Yes, because this value is decreasing and then it shows increasing. So definitely it went down, came up. So there is a relative extrema, relative minimum there. Can we move on? Yeah. Now, what did I want to cover? Yeah, there are more questions I said, right? Then only we'll go to a lot of questions are there. This will be the last question for that matter in this topic. How about this? I didn't ask you the free. Did I miss it? Oh yeah. How about this? Yeah, this one I would like you to try, guys. Yeah, see, I would like you to try this one. Try this one. Yeah, I would like you to try this one. This one is based on whatever we have discussed. The distance between f of theta and the pole is increasing or decreasing on the interval 5 pi by 4 to 3 pi by 2. Let me underline that 5 pi by 4 to 3 pi by 2. 5 pi by 4 to 3 pi by 2. Okay, guys. I really want you to try this one. Let me know. In the meantime, I wanted to do it in the calculator and see quick. So I graphed it. What did you want to do? How to set up, right? Okay. Table set. Table set, you can say, right? Can say pi by 12. What is pi by 12? Pi by 12 is 3.14 by 12. Pi to 2 pi, right? Pi to 2 pi. This can be 12 maybe. Pi by 12. You're going to do and send, guys?
Wait, Miss Priya, do we have to give the explanation? Because I just sent the
Send
answer.
it to me. Yeah, send the answer to me. That's enough. Okay, so I'm just checking, guys. Hold on. 3.5. Okay, that's good. 0.5 minus. Yeah, you can get it easily. Yeah, we'll do this. We'll do how to put it into the calculator. I'll show you. I'll bring up a calculator and show you. I need to check the answer for this one, right? Negative. You the answers that came in, it's a little meaning. I feel sad. I think I did not reach you guys properly. I feel. Okay, I'll wait for more answers. Maybe Nitin and Dhyani, do you want to see what is going on in the interval? How did you conclude, Dhyani? Can I ask you?
Yeah, like um between the between the interval, like the R value is like negative, and like it's also decreasing. So since it's
R value is negative,
yeah,
decreasing, then
yeah,
both are bad, right?
yeah, they're both bad. So since they're the same, then doesn't that mean they're like
Both are
going
bad. Both are bad or both are good means it's moving towards the pole or away from the pole.
towards?
Oh,
It's
isn't it? It's moving away from the pole. If
Oh,
it's the same.
yeah, both are good or both are bad, it's moving away.
oh wait, then I confused it. Yeah,
No,
if
no,
it's
no problem. See, here is where you can rectify. It's moving away means distance from the pole.
if it's away, then it'd be increasing. Yeah.
Yeah, distance from the pole increasing. Make sense?
Yeah, I thought if they were both bad, then I confused it with like going.
Both bad or both good. Both bad or both good, it's the same.
Mhm.
See, don't memorize this. That's why we understood how it came through.
Yeah.
Once you understand how that table comes in, then you can put it into your head. Anytime if you forget, you can bring it back. Abhiram, are we clear? Huh?
Yeah, it's increasing.
Okay, increasing. Yeah, we've also said increasing. Yeah, I saw that. Ritik, are we clear?
Yeah.
Okay, if you're not clear, this is the time to ask though. Okay, now I really want to go ahead with the few more questions that I had and then put it into the calculator for what Ritik asked. How about this? Yeah, this one is as well. Oh, but I gave this to you, right? No, no, I don't think so. How about this? The distance between f of theta and the pole is increasing or decreasing on the interval pi to 7 pi by 6. Let me mark that. These are questions which will help you understand, and any problem you can tackle once you understand how this works. Pi to 7 pi by 6. So what happens here? This is nice one. Oh, yes, Yashita. Okay, Yashita, noted. Guys, try this one, guys. Really, you can learn it here and then use it at school, right? If you didn't understand, I'll help you. Oh, that's right, Supraj. Supraj, did you understand how?
Yeah.
Okay, let's call it F. I'm doing only one problem with all the details included. That's right, Nidhi. That's right, Ritik. I hope you understood now. Yeah, all of you got it, I think. So this sixth, if you have done it, if you're clear, we can move on to the F question. Find the average rate of change between these two are the X values. But the thing is, we need to find the Y values. F of 3 pi by 2 is what? This one, minus 2 in here. F of 7 pi by 4 is what in here? Minus 0.53. Now, the difference between those two, you need to be careful here. 3 pi by 2 and 7 pi by 4 you're using, right? So you will use minus 0.53 minus 2 divide by 7 pi by 4 minus 3 pi by 2. You need to be careful with the plus and minuses. That is right. So one correct, Nisha. More questions coming your way. Another 2 more questions, then we'll put it into the calculator and see. That's the plan. If you are okay not doing it as well, message me. I understood. I'm not going to do it. I rely on you. Don't just keep quiet, guys.
Miss Priya, which are you posting the questions?
One second, wait. Find the average rate of change of f between 3 pi by 2 and 7 pi by 4. Ritik, are we clear?
So that's what we do?
Yes.
Okay.
One or two more questions are there. With that, I'll go ahead and show in the calculator. Yeah, that's correct. Supraj, Vibha, Naisha. Average rate of change is done. Then you don't have to wait. Check this out. Yeah, see, okay. This one let's do and then we'll do the next one. Last 2 questions, guys, on this. How about this? On what intervals must f of theta be 0? How can we determine that? When will it cross 0? When it goes from positive to negative, right? So you can just mention the intervals as well. On which interval it should go to 0. At least in the given interval. F of 5 pi by 3.
Wait, for G, we're finding which R value or
On what intervals means you always in a coordinate plane, xy coordinate plane, if you ask for the intervals, what do? You always say it in terms of x, right? I'm seeking the intervals for which f of theta can be 0. Where my r value will go to 0. Good job. When it goes from, see, it's decreasing. See here, 0.5 positive went to a negative. That means what? In a graph, right, in a coordinate graph, right, when will it touch the x-axis? Whenever it goes from positive to negative or negative to positive, wherever it is, that is when you come across zeros. Same thing here.
so we find when it's at the pole.
That's what they're asking. When is it meeting the pole? Which intervals? So I can say 7 pi by 6 between some point. We don't know what is that point. This is one interval.
Oh, so they're not specifically asking.
The other, on what intervals, right? Other interval is, see here, negative to positive. 7 pi by 4, comma, 11 pi by 6. Make sense? The last question I had is, last question is a little tricky. Let's see. Now, I'm going to erase all this off. This is the last question for this one. Any rate of change. Now, I would like you to compare the estimated value to the real value. Real value of f of pi by 3 is this. How do you get an estimated value? We already did this. This is another thing for you to do. Exercise problem for you to do, right? I already showed you one. How did we do? F of 5 pi by 3. We need to estimate. So, like we wrote the equation, remember, y1 minus y equal to m times x1 minus x is the equation of the line. But here, this is no longer y and x. I will write it down as r1 minus r equal to the slope times.
Wait, so I have a question.
Yeah, go ahead.
Is it asking us to find like the residual or like?
Yeah, we are trying to find the estimated value using the equation of the line of the graph.
Okay.
We are trying to find the estimated value. Like, since this the real value is given, this is my estimated value. How am I going to find the estimated value? First, I'll find the slope. Remember, we did right. First, I'll find the slope, then substitute the slope and one of the points.
But don't we already have the equation?
Oh, we already have the equation. Where did we have?
I thought the r equals f of theta 3 plus 5. Is that the equation?
No, no, no. Like, we did, right? Here. Like this equation we can build up, right? We counted the slope, right? We took 2 points, found out the slope. Literally, if you take these 2 points, right? Take these 2 points, what is the slope?
Wait, so my question is, what is that like where it says on above the table? What is that for this table?
This is for this table. Perfectly right. But how do I find the estimated value? How do I find the estimated value? For literally, I have to find f of 5 pi by 3. What is the value I have to find? So I find the equation of the graph. And then in the equation of the graph, I substitute my theta value as 5 pi by 3 and find out my f theta.
Oh, okay.
Does that make sense?
Yeah.
So first of all, I have to find the m value. M value, did you find out for anywhere? Did you find anywhere? No, right? We never found it. So we have to, yeah, we have to find. See, do this alone. This is the last problem. Why don't you do it? So you get used to it to find the estimated value. You have to find m value. There is a graph, right? There's a table given. So I now want to show you, if they give you just the equation, you have to find these values in the table. That's what I want to show you in the calculator. Once you find it, please send it to me. What is the estimated value? The real actual value is here. But what is the estimated value of f of pi? First, you need to find the m value. Once you have the
And for r1 and theta 1, we can just use any
any
value.
point, yeah, I would use some near points. 5 pi by 3. I'll choose 3 pi by 2 and 5 pi by 3. Let's say by 2 minus 1.33 divided by 3 pi by 2 minus 5 pi by 3. That will be your m value. And then you can use 3 pi by 2. 3 pi by 2. I can use 3 pi by 2 minus theta. Whatever is your m value. And then r1 is what? Minus 2 minus r. Now you're going to find it for 5 pi by 3, right? Then substitute 5 pi by 3 here. Find out your r value. That is your estimated r value at 5 pi by 3. If you guys say no, auntie, we can go ahead, then we'll go.
We can go ahead.
Yeah, I think we can go ahead. It's just computation, right? Can I move on?
Yeah.
Okay. Now, I really wanted to show this in a graph, right? 3 plus 5 sin theta. Let me get the calculator in Google Chrome. I can't show them this calculator, right? Okay. Let me go ahead and show you the calculator. How do I show you? Chrome. Yeah, I got it. Okay. You see the TA84 calculator?
Yeah.
Okay, the equation was 3 plus 5 sin theta. Let me put down 3 plus 5 sin theta pi to 2 pi. 3 plus 5 sine theta, that was r. And then it was pi to 2 pi was the interval, correct?
Yeah.
Let's see this one. So here, as I said, right, very likely in the exam, they are going to give you the equation, ask you to do the table by yourself. It's not hard, okay? So
Will,
here,
will we have TI-84 on the exam, or will it be Desmos?
you're
I
asking
think
me,
we get both on the test.
Okay.
yeah, I mean, I honestly don't know, okay? But as a person who has worked in distributing the test, right, I know that even digitally they can provide you both.
Okay.
Okay, in the interface itself, if you go to calculator, there'll be two types of calculators, is what I would think.
Yeah, we took a practice test and it on the on the official Blue Book website will have Desmos and then they'll also give you a handheld calculator.
Oh, handheld TA84?
That's what it said on the instructions.
Okay, that's good. Okay, but you take your own calculators, guys. You take the calculator that you are used to. Don't use the calculators that they give. It's going to slow you down like anything. Okay, now I go to mode. What happened? If I go to mode, I go down. This is polar, right? Yeah, so I will select that. Come back. I need to type a function, right? So I'll just go to y equal to, see it's really coming in as R1 already, right? So I will type 3 plus 5 sine theta. 5 sine is where? Sine theta. See, this is your coordinates. For that matter, right, I wanted to show you this as well. See, this particular key, right? See, nice and clear. See, x, t, parametric equations, you use this button for typing t. Polar, you use this key for typing theta. For sequences, you use that button for typing n. Now, this is our equation, right? That's it. And you go to graph. It will graph it, but that's not what I want, right? What I want is a table. For the table, let me go to the table. Where is the table?
Second trace.
Yeah. So this one, right? Table.
Yeah, second graph. Sorry.
Oh, it already populated. Oh my gosh. Okay, but you know why it already populated in my in my physical calculator? I didn't have this. You know why? Sometimes what happens is second table set when you go, see here the table start is 0, the increments are 1, independent is auto, dependent is auto. This is where you set up your table. If you say ask and ask, you will have to type it in. If it is set to auto and auto, then it will type x and y values for you by itself. So here, let's go to the table again. Where is the table? This one. Here, when you look at it, it is giving it like this. Do you see 0, 1, 2, 3? This is not what we want. Basically, as I said, right, we want it from pi to 2 pi. You want to decide this table, then only you can answer all those questions, right? So r, theta, I'm sorry, theta and r, right? So you would want from pi to 2 pi in increments of pi by 12 or pi by 6. Usually I'll go ahead with a pi by 6. So next one should be pi plus pi by 6. Then the next one should be pi plus pi by 6 plus pi by 6. It has to be like that, right? In this scenario, right, what I would do, I would go ahead to table set. I need to change, hold on. I'll go to table set. Here, see, the minimum value is pi. I'll go ahead and type a pi in here as the theta min. And then the theta max is 2 pi. 2 pi is already in there. 6.28 is 2 pi. And the step right, I would put it as pi by 6. Pi divide by 6. The step means how the theta should increase. So if you have that, I think that should be good. Let's see. Table. It didn't auto set down. Let's see what happened. What did I do? Oh my God. Okay, sorry. Table start is pi. It didn't set to pi. Table start is pi. Table start is pi. Table. Okay. The delta is what? Pi by 6, right? Pi Divided by 6. How should it increase? Auto, auto. That's good. So now let me go to table. See, did you get it? Does it help?
Yeah, it does.
Now you can just draw your physical table, fill it in.
So how would you get the pi over 4 values?
How do you get the,
Pi over 4 values.
what do you mean by that?
Like
I'm not getting.
pi by 4 on, like, on the unit circle, how it's pi by 4. How would you get those values? Would you just change the uh like
Oh, you
increment?
want this to be in, you want this to be appearing as pi, yeah?
No, like pi by, like, how would you make it so that it gets all the unit circle values?
Oh, you can change your interval, right?
Oh, would you change it to pi over 12 if you wanted that?
Ritik, somewhere I'm missing you. One is, okay, let me tell you that you can change the interval. Now I have typed in from pi to 2 pi. So if you see this, pi to 2 pi is all what you want, in the sense pi is 3.14, 6.28 is
No,
2.
what my question is, like, how would you, so you said the increments that you added was pi by 6.
Yeah.
So how would you get the pi by 4 like values?
Okay, you then increment it however you want to, right? If you want pi by 4, right, what will be the increment value? Meaning, you want for pi by 4, you want it for pi by 4. You want it in increments of pi by 4, you mean?
Yeah, and like pi by 6. How do you get both of those? Is there like a
I'll go with the pi by 12. Pi by 12 will provide me that. I don't know. Or pi by 24. Am I
okay.
making sense?
Yeah, yeah.
You want it for, okay, so you want this. Let me show you. Are you wanting this is what you're asking? Let me clarify from you and then I'll help you. Is this what you're wanting?
Yeah, like these, how would you get
What
all
is
of
it?
these
Okay,
values?
what
Because
is the
right
difference?
now we can only see the values for 7 pi over 6, 4 pi over 3. We can't see any of the values at over 4.
Okay. Okay, by 4 if you want. Is there a common difference between these? Let me see. Let me think about it and tell, Ritik. I'll
Okay.
message you. I'll
Okay.
message you.
Mm-hmm.
Uh, well, meaning I would think of having the LCM of these. That is easier, right? Well, let's see. 6 3 is 6 6 4 is 24. Yeah, if you have 24, right? Pi by 24 as your interval, right? You can skip some of these. So basically, let's see. I can do it now itself. Let's see. If you show pi by 24, I'll do this and let you go, guys. Okay. Pi by 24. If I have the step as, oh, why am I not? Oh, I need to change. Hold on. So come down. Yep, I'll put it as pi by 24. Then I should get all the values as my honest start. Let me see. Yeah, it will. Okay, now let me go to table. You see, you have,
Oh, now. Oh, okay.
you see what I'm meaning? Because that's the LCM of 643, right?
Mm-hmm.
So for pi, you have a 3. 7 pi by 6, you have a 0.5, but you need to skip those. You see what I mean? Because you're
Yeah.
taking pi by 24. So pi by 24, pi by 24, pi by 24, pi by 24, pi by. So here you need, meaning you need to skip whatever you need, you'll have to go with that. You see what I mean? 3,
Yeah.
0.5, and then minus 0.53. Then you have to come down, right? Let's see. Are you getting what you want?
Yeah.
But one another thing, what I am not sure is, can you make theta appear as pi by, like, what is it there? I have to check.
Okay.
That I don't know. But this is one way of getting all the values at one shot. But you need to skip some of these intervals because your step interval is pi by 24 here. But you're wanting a little different, right? Meaning
Yeah.
some are pi by 3, some are pi by 4, right?
Mm-hmm.
Pi by 6 and pi by 4, right? So you might have to skip some of these, but pi by 24 is a good interval to have all those values in. Make
Okay.
sense?
Yeah.
Yep. Any questions?
No.
Okay, I'll stop here. Next week, I'm going to decide what to do, guys. I'll keep you posted in the group.
Okay.
Okay.
Bye.
Yeah, guys. Bye bye.
Bye, Auntie.
Bye, guys.
Thank you.
Bye, guys.